Hello, everyone, and welcome to Traditional Synergy Unit Testing. My name is Liz, and I'm a digital producer here at Synergex, and I'm joined by Nick Tammadge, who's a software engineer and today's presenter. We're excited to have you all here, and before we start, just a couple of items about this presentation. The webinar is being recorded, and the recording will be available tomorrow on our YouTube channel. There's a link to the channel in the chat area currently, and if you subscribe, you'll be notified as soon as we publish new content. And we'll have some time at the end of the presentation for questions, but if something pops into your head before then, you're more than welcome to post it in the questions panel. So with that, I will hand things over to our presenter. Take it away, Nick.
Alrighty, so unit testing and traditional synergy. Just real quick, what we're talking about today, in case anyone is unfamiliar with the term unit testing or unit testing in general, we'll do a quick overview just so we can all roughly be on the same page here. We'll then dive into the feature, what comes with it, all that jazz. We'll do a couple of demos. We'll do some new dev style, a new dev style demo where we're doing de-serializer creation for JSON and XML de-serializers. And then we'll actually go and refactor some of the repository product code to show that you can do this in existing applications. And then if you have questions on why you should use the feature, you have your own tests already, why you should be unit testing, we should hopefully be able to answer those too after the demos. So what is unit testing? Well, at its core, you're testing the smallest individual chunks of code that you possibly can. In .NET languages, you're testing methods. In traditional Synergy, we're testing subroutines, functions, and methods, and that's on parity with Synergy.NET as well. For testing operations, you're looking to test basically anything that you can in the application. If you're displaying text on the screen, if you're updating values like in a table or something, or you're doing data validation, any piece of your business logic, any of that stuff, that's the stuff that you want to be testing. You want to start from the smallest components that you possibly can, the pieces that make up your large complex operations, and then start building tests for complex operations after you're sure that the foundational pieces are good, and then just keep building until you have a library of tests for your whole application. As far as the feature is concerned, it comes sort of in three parts. We have the traditional test framework, which ships in SDI, and this is sort of the meat and potatoes of the whole thing. It comes with the assert class, which is on as close as we could get it to the .NET assert class for .NET testing. It comes with a whole bunch of methods like are equal, fail, are not equal, are same, all those sorts of things. And they come with a whole bunch of overloads. If you're interested in everything for that, that's on the documentation online. But this is really the thing that describes a pass-fail condition for your unit tests. So you're going to be using this quite a bit. If you don't use this, you are probably going to end up with a passing test all the time because you're really not describing a test condition. You're going to have test attributes, which describe metadata on your test methods or test subroutines. It should hopefully be able to demonstrate that we can do this for subroutines. But yeah, it's just metadata. It describes what initializes your tests, what data your test is going to use, if you have properties like boilerplate stuff that is going to go into every method, what category it falls into, like all that stuff. There's a whole list of attributes as well online. You should go check this out so you know what you're working with. We do ship a test runner DBR in SDI as well. It's because we do a little bit of black magic to get the tests to run. So rather than have you guys try and figure that out on your own, we've done it for you. This will run every time that you do the tests. We load your test methods or test routines into it, and it runs your tests, and it's magic. But because of this magic, the minimum runtime version that we had set for the unit tests is 11.11d. because we had to pull 11.1.1d, it effectively makes 11.1.1e the minimum version, but you're not going to be able to test against 10.3.3g runtime, even though that option is available in Visual Studio. The feature actually released in SDI in 10.1 or 11.1.1d, sorry, but there were enhancements in 11.1.1e. I would recommend using 11.1.1e for SDI as well. As far as Visual Studio is concerned, we added a new project template. It looks a lot like the .NET unit test. It's just for traditional. You can search for it. It's all there. And at its core, it's really just an ELB with the test framework reference to the project and a default item, a unit test item. And so there's a new item template as well. And we can show those off today as well. There's Test Explorer integration, which if you're unfamiliar with the Test Explorer, it's where you display your tests in Visual Studio. It's where you run your tests. It's where you see your results, see the runtime, see any errors that come out, and all that jazz. So that's really neat to have. You get the full debugging support for traditional Synergy applications with your unit tests as well. It functions exactly the same, and we can show that off today. We do have full Visual Studio 2019 support. The 2017 support is functional, but if you want the best experience, I would highly recommend 2019. There's a couple issues in 2017 that don't make it the greatest experience. And the last piece of this is the command line integration. Fortunately, Microsoft has this nifty tool called VS Test Console, and we just integrated with that so you can run your tests from the command line. And so if you're familiar with .NET tests, you would run VS Test Console and pass it the path to your DLL that has all your tests. You just pass it for traditional tests, you just pass it the ELB instead. Really straightforward. You just down here, it's exactly this. It's super easy to do. And if you're doing continuous integration, this is the thing you want to be doing because it's quick, it's fast. You don't have to have anyone in the loop as far as running tests are concerned. All right, and then we're just going to go straight into our demos. All right, so I'm on a VM here. Setting up something on the other monitor. Okay, so on a VM here, it has an internal build of 11.1.1e because we were fixing some additional stuff. I believe this build is coming out soon, but I don't have the exact time frame on it. So keep an eye out for that. All right, so we are just going to start making our, we're going to start with the new dev style stuff. So we're going to start with our de-serializers. We are going to deserialize into just an object. We're pretending that we're writing an application for, say, like a home improvement store. So you're going to, when the application loads, it's going to read a whole bunch of your item info, like what items you have in the store, what their item numbers are, what the prices are. So that's what we're going to do, and we're going to support JSON and XML formats. So we are just going to start with a data object library, just to hold all the data objects that we're parsing into. And we need a good name for our app. So because I can name things good, I'm going to call it my app. File item for sanity, because we're going to define what our item looks like here. So just real simple. We got a name, a number, and a price on the item. Really straightforward. We can now move on to our de-serializers. So same deal. Going to need a library to do this. I'm just going to call this de-serializer. And in a test-driven development approach to this, which is what I'm going to try and demonstrate today, you test against the interface rather than the implementation of what you've done. So what that means for us is instead of actually testing against the JSON de-serializer and the XML de-serializer, we're going to test against a generic de-serializer. And so that's what I'm going to define first. Let's just grab our basic implementation here. And so part of our testing against the interface in traditional, we're going to have to use an abstract class, but it'll function the same way for us. So we have our method that we're going to extend or override in the XML and JSON deserializers. And then we just have this utility method that everything's going to have to read content in from a file that we give it. You're going to note here that I need to reference actually the test framework. And you're probably thinking, but you're not doing tests here. You're absolutely right. I'm sort of cheating here because I know inside of the test framework namespace, we wrote some utility stuff to let us as .NET programmers do traditional Synergy things. The SDI team, do traditional Synergy things easier for us. And so there's a few things in this namespace, like file. I think there's environment. There might be a couple of other things, maybe math, but they have a couple of utility methods on them. It wasn't really designed for external consumption. It's not documented anywhere. But if you want to go playing around in there and seeing what you can find and what you can use, go for it. If you like what's in there, let us know, probably on ideas. Maybe we can add some more stuff, but no promises on that one. All right, so done cheating here. Looking ahead, I am going to need to parse into my items. So I'll just go ahead and add the reference to that project ahead of time. All right, and then we need our actual deserializers that are going to deserialize things. So we're going to have JSON de-serializer, if I can spell. And then we're going to have our XML de-serializer. All right. And so we're just going to do our basic implementation here just to wire up our XML and JSON deserializers to our interface, our abstract class. And so what that looks like here is just extending the deserializer, overriding the method, and then in a test-driven development approach, we're going to throw an exception here just so that A, if someone tries to use this before we're done implementing this, they aren't going to be able to, and B, so we can actually have a failing test when we do the initial implementation of the test. That's part of test-driven development. You actually want to start with a failing test. So then when it passes, you know you've done the implementation correctly. All right, so going to do the same thing for our JSON deserializer, and it's actually going to look the same, just with JSON instead of XML. And because at runtime for this application, we're not going to know what file we've been handed at any given point, we're going to need a deserializer factory to pick the right deserializer to do the deserialize operation. So we're going to go ahead and add that. And this isn't going to get an interface because it's not, there's only ever going to be one definition of this, but we are still going to do test-driven development here where we're going to write a failing test first, do the implementation, and then make sure we get a passing test out of it. So let's just stub our implementation here. And so what this is an enum just to handle the type of deserializer that we're going to want, just so we can pass it around between methods. We're only going to handle JSON XML at the moment, and if we get something else, we're going to call it unknown. Exceptions for not implemented at the moment, but we're going to have a method that picks the deserializer that we're going to use, or the deserializer type, and then one that returns our deserializer. And now it's time to add our tests, the fun part. So you can see I've used the unit test quite a bit here, but you can search for it. Unit test traditional pops up in Visual Studio, just like every other template that we have. And we're going to call this de-serializer tests. This is just an organization thing. You might have one project for all your tests and different test files and folders. I don't think there's a hard and fast rule on how you're supposed to do that organization. All right, and so let us stub our de-serializer factory tests. I am going to need to add a reference to both of these because we're going to be using stuff out of both of those projects. And let's think about our de-serializer factory, what our de-serializer factory tests are going to be. If we get a file that we know how to handle, we should get the correct type out of it as far as our enum is concerned. And then we should get a good value. We should get a deserializer value out of our get deserializer method. We're going to say if we don't have a how do I want to explain this? If we don't have a file that we know how to parse, we're going to get back our unknown value for our which deserializer method. And then for our get deserializer, we're going to say we're just going to throw an exception, and then something else that we're not going to implement today is going to handle that. All right. So let's just go ahead and add those test stubs. So real good. Determine that we're going to get a JSON, an XML deserializer. If I missed a couple of test conditions, if the file doesn't exist, we should get our unknown condition, and unknown when the file does exist, but it has the wrong extension, and then our exception when we have unknown. Awesome. And then this is showing off some of the attributes. Every test method is going to get a test method. Every test subroutine is going to get a test subroutine. And just for organization, I've declared that these are of the de-serializer factory test category. All right, so let's go and add our de-serializer tests. And if you come under this test tab, we do have our traditional unit test item. We're going to call this one JSON de-serializer tests. And we need an XML deserializer tests. Same deal. Oops, did not mean to double click that. Just rename this real quick. Okay, and let's think about our deserializer for a second. What do we expect to happen here? Well, if we give it an empty file, let's assume that we're always going to give it a valid file. If we give it an empty file, we should get back we're going to say a list of no items, none of our item class that we've declared over here. If the file has one item, we'll get back one item or a list of one item. And then if we have multiple items, we'll get back a list of multiple items, an array list of multiple items. So let's go ahead and add those test stubs. So there's our XML deserializer tests, and then our JSON deserializer tests. The cool part about these deserializers is that they're going to have the same test conditions, which is awesome for us. And this I think is erroneous red squiggles. Let's go ahead and build, make sure that build's good. Red squiggles go away, awesome. And our tests now appear in our test explorer. We come over here and expand this. The way I currently have them organized is by project, namespace, class, and then test. You can organize them however you want. I believe it's somewhere up here. You can organize the tests however you want. But this is how I'm going to work with these today. And let's just go ahead and run these real quick. And these should all fail, right? Awesome. No, we have passing tests. We can walk away. We're done. We're the best programmers ever. Not quite. If we look at all of our methods here, I didn't assert anything. I don't have a test condition. So let's go ahead and add all of our test conditions now. So we'll start with de-serializer factory. It's a little bit more in here, but at the end of the day, right, we're going to say we expect a de-serializer type for determined type methods, test methods, and then give it a file that we expect that type out of. You'll notice that I am using this test property, declaring a property test file and pathing it to a file. I'll need to add that in a second. But you're wondering, where does this magic come in? Well, if we come up to our test initialize, if we have declared this property on a test method, we're just going to set our class property or class field to that value, and then we'll be able to use that for the tests. This lets us do boilerplate stuff for every test really easily. So I don't have to do this whole set operation for every test in here. And so we're declaring also that for our exception that we're going to get a file IO exception. If we throw any other exception, it won't get caught here. So we should actually fail out of the test if we have an uncaught exception. And then if we don't throw an exception, we're just going to straight fail the test. Awesome. So there's our de-serializer factory tests. And if we just run these real quick, we'll show that it fails. I'm running them by the class this time. And awesome, they all fail. That's cool. Let's go ahead and implement our de-serializer tests. JSON first. And this is really straightforward. Make sure that if we have an empty file, still need to add this file, but when our empty file comes in, we expect 0. If we have a single item, we're going to get 1 item out, and it should be equal to this test item that we've declared. For our multiple items test, we're going to have 5 items, just some number greater than 1, make sure that we have 5, and make sure that we can find an item. This is effectively a redundant test, but we can still do it because the index of should do an equals comparison to give us back an index. And the nice thing about this is, for the de-serializers anyways, is that these tests are exactly the same, just with our XML de-serializer instead of a JSON de-serializer and XML files instead of JSON files. You'll notice that for both tests, though, I am declaring our test de-serializer as a de-serializer type rather than the specific de-serializer implementation. Again, part of test-driven development, we're testing against the abstract class interface instead of the actual implementation. And then I'm using our de-serializer factory to get the correct de-serializer for each test. Awesome. So let's go ahead and add those files now that I keep talking about. Just gonna have folder test data files. We're gonna need all of these guys. All right, and just to prove that the content in here is what I say it is, just empty files, 5 items, single item, and then a file that we aren't going to be able to do anything with. So let's close some of these. All right. Now we should be able to build. Awesome, everything's good. Run all our tests, and we should have failing tests across the board. Awesome. This is what we want. Failing tests are good tests. All right. Let's do our de-serializer factory implementation, since we need that before we do the de-serializer implementations themselves. Let me do one piece here just to show the tests light up one at a time. So I've implemented our which de-serializer method, the method that picks the correct de-serializer type based on the file that we've given it. And we should expect 3 or 4 of our tests to light up. 4 of our tests. Yeah. Okay. So the one that doesn't light up is our method that's still not implemented, and you can see that we do get our not implemented error message out. We do get an exception in here. This is all expected. So let's go ahead and implement the whole thing now. And we'll run this from the project just to show that everything starts lighting up one at a time here. Awesome. So our factory tests are good. We'll come down to our JSON deserializer, not the tests, the actual deserializer. We're going to do our implementation of this deserialize method now, which is fairly straightforward. Read the data in, parse it as JSON, store everything in an item, add the item to the list, return the list when we're done. Cool. And so we should expect our JSON deserializer tests all run green now because we've done this deserialize implementation. Not quite. Why? Well, you'll see in our error messages here, we have a condition is false and in objects are not equal error here. I think we have a bug in our test details, Marty, if you want to take a note of that. But so what this is telling us, if we go to our single item, objects are not equal. So this assert is failing. For our 5 items test, condition is false. This condition is what's returning false. Why is that? Well, if we go back to our item implementation, right? Item implicitly overrides the generic object class, which has its own equals method. We haven't overridden that to tell it how to do this comparison, so we'll go ahead and do that right now. And then we can run these tests, and then they should pass. Let it build first. Awesome. Passing tests, like we wanted. And not the tests again. And then we'll go ahead and do the XML serializer implementation. Fortunately, this will get to build on the fact that we've implemented the equals method on the item class. I do need to still add a reference to the Synergy XML DLB for this. There we are. I've done something. I copied the tests into the deserializer. There we go. All right. Less horribly bad. Real quick, just parse the item or parse the file, iterate through the nodes to find the correct item or the items node, parse each item in the list, return the list. Awesome. And now all of our tests should run green. Cool. Just like we wanted. And just to demo that we can do this with subroutines too, we're going to do a subroutine, my subroutine, assert. And you can see some of the methods that we offer here. We're just going to do is true, false, just to demo this. And we need to tell the test explorer that this is a test. So we're going to use our metadata here for test initialize attribute. Or not our test initialize, what am I talking about? This is test method. There's no difference for the test explorer whether it's a subroutine, function, or method. So we didn't make an additional attribute for it. They're all test methods as far as this is concerned. Shows up, subroutines show up under the global namespace. We can run this one individually. This should fail, right? And then change this to true. Awesome. So this is all working as intended. And just to show the command line integration, all we have to do is run vs test console.exe and then give it the path to our test ELB, which for us is in C test my app debug x64 de-serializer tests ELB. And this is the output that you're going to see if you run this by yourself, or manually rather. And notice 12 tests. We have all the same tests, same test condition, and we run 12 tests in under a second, which is fantastic. All right, so now let's go see what trouble we can get into refactoring repository code. So let me just set up my environment real quick. All right. And just load this. Okay, and just to prove that this is the repository project that we're all familiar with, let's just start debugging here. The repository product. You'll notice in the build output, it references build numbers lower than 1111D. The test runner will force the 1111D runtime minimum. So you can still have it build the way that you want. It's just going to test against a different runtime version. Right. So repository project. Repository product. We're all good here. Let's start refactoring some of this stuff. All right. We are going to want to do this load footer method. I've pre-picked this method because this subroutine rather, because it demonstrates quite a bit. If we think about what this is going to do, we can start this back up again. This loads the text into this bottom section of repository here. So fairly reasonable that we will want to make sure that we're producing the right text, that this all gets loaded correctly. So let's go and find out where this lives. This lives inside of our comlib project. Comlib is an object library, not a DBR, so that is good for us. We don't have to move this anywhere. If this was in a DBR project, either a traditional app or a multi-mainline, we would have to move this out into a different library because we cannot run tests on methods that are in a DBR. It has to be in an ELB or an OLB. So fortunately for us, this is in OLB, so we don't have to move this at all, but we do need our test projects. So let's go ahead and add this test project. Yeah, we're good there. And we're just going to call this one tests. And we're going to call this footer load tests to be descriptive. And for simplicity, I'm just going to paste our full test implementation in here. So what this is going to do is we're going to get an ID for our message that's defined somewhere else. We're going to load it in. If our footer comes back with a non-zero length, we actually have text in there. Awesome. We can run the test. If it comes back 0 length, we don't have text in there. So we're going to fail the test. You'll notice that this routine here actually does the message acquisition. So we would really want to have another test for this and all of the various inputs and outputs that we can provide to this routine. I'm not going to do that today, but this lets us build confidence in this actually getting us the correct messages back. And then we'll know that we are expecting the correct message to get loaded when we call this subroutine. Cool. I do need to add a couple of references here. Namely, first to our ComLib project, because that's where this routine lives. And then we need our toolkit library, because we are actually doing toolkit operations here. Let's go ahead and build this and see what horrible badness we can get ourselves into. Let's run the test. Awesome, failing test. Let's check our output here. Cannot access name, global routine, load footer, global data section, blah, blah. Okay, so we've missed some initialization. We're going to have to go find the initialization that we missed. Let's just start scrolling up here, load columns, not it, do all program initialization. Yeah, that's probably it. Let's go find out where this guy lives. And this guy does, in fact, live inside of RPS DBL, which is in our repository project, which is a DBR project, or it outputs a DBR. So we're going to have to move this. So let's go ahead and add a new library so we can move this into somewhere. We're just going to call this repository utils. And because I can name things really well, this is not going to conflict at all with the RPS util project. We're doing good things here. And we're just going to rename this file. Let's call it application management. It's probably too broad, but we're on the clock here for a presentation. We aren't getting too fancy. All right, and we can actually just cut this out, paste this in here. We are going to have to reference, if we check the references, well, yeah, we are going to have to reference the new library in our repository projects. So we still have access to that routine. And we're going to have to reference the library in our tests project to have access to that routine. And in our tests, I don't have a test initialize at the moment, so I need to add that since that's what we're doing here. Test initialize, or at least that's where this is going to go. Public method. If we were to check the way this thing's called, we need 3 variables just to store data into. They aren't going to get used by anything outside of the test initialize. So we're just going to call this A255 because I can name things really well. And this is ICS DD startup. And we can build this, and we should have good stuff. We don't have good stuff. Why don't we have good stuff? We're going to think about this for a second. Our repository project has references to these other projects. We actually need those references in our library as well. So we're going to go ahead and add those. All right, we can build this now. And we should be good. The world's still on fire. Why is the world still on fire? So we have a uniquely defined routine already. So we're just going to go ahead and find this. We probably have a .include somewhere. So we're going to search for this. We're going to just comment this out for this region real quick. It's titled VMS. We're probably going to break things for VMS if we do this. So either we're going to have to come back and fix this later, or we're going to pass this off to some poor fool and they're going to have to fix something that we broke. But this should get us to build. No, it's all broken still. Why is it all broken still? If we recall, our Comlib project was an OLB, and the way OLB projects work, because we have it referenced both in repository utils and the test library, and we reference repository utils in the test library, we're getting a name collision effectively. So our easy solution is actually just to remove the comlib reference. Good build, can run tests. Awesome. Well, we're at least running tests, so this is progress. We can't find this method, so we've not registered something correctly. Let's go debug and figure out what we can't do. So just set a breakpoint in our test initialize. It's going to take a second to get the debugging experience to start up. But we can step into here, and we're going to step and just keep stepping until we break. All right, so we broke in our tests. We're missing these methods, or at least we're missing this one. If we were to fix this one, we'd find out we were missing these two as well. We're also missing these if we were going to do this all one at a time. I'm not going to do that because I'm actually running short on time here. So let's stop debugging. Oops. So let's go find out where these things are. These things probably all live in RPS. So yeah, so we got stuff in here. So we need our RPS close. This is just going to come out into not our footer load tests, our application management. And back over, we're going to do close tab set, close text, close window, size window. And this is probably a good point to mention. You will probably find stuff that you wish you could have done differently, or stuff that doesn't make sense anymore. It's a really good opportunity while you're writing your tests to be thinking about that and maybe do some refactoring, do some code cleanup. So we're going to paste all those. I believe I am still missing two here. Missing a help method. And no, it's just this help. method, which is actually a subroutine. And let's go ahead and run our tests. Actually broken something that I didn't expect to. Paying my tax to the demo gods right now. I missed one, didn't I? Close list. Yeah, I missed that guy. Whoops. There we go. All right, now we can run tests. We should get a passing test. Passing test, awesome. And even that complex window operation, 79 milliseconds. It is, well, complex window operation. If we were to try and do a UI test to do the same thing, we would at least be talking on the order of seconds, maybe somewhere in the ballpark of 30 seconds. Manual testing, maybe a minute or two. So we're doing stuff lightning fast here. I do also want to point out real quick. Let's move our breakpoint and start debugging again. That I do want to make the point that if you're doing window operations, the test runner in the test application that you've seen pop up actually reflects the operations that you've done, right? So we've actually loaded our text in here. It's really neat. You can see what you're doing. You can see what the test looks like. If you're doing something like this and it fails, you should be able to see why. All right, and that's it for the demos. Going to come back to the presentation real quick. All right, and so this is just another new feature in Visual Studio. It's got a whole bunch of features in it. Why should you be unit testing? Why should you use this feature? It's complicated. We break things. It's a little bit of a mess. Well, I hope I at least made a case that test-driven development is a good way to actually spec new features, spec new products or components of products, because you'll never end up in a scenario where you're wondering what was the output supposed to be from here. You've already defined the output. You should get the right information in and out every time. I think in both demos, we showed that it promotes good compartmentalization and organization in your code. Like the repository code needed a lot of moving stuff around and compartmentalizing stuff to even be able to run the test, let alone pass the test. If you're running a lot of tests, you should actually be thinking about how to break your code and what those failure scenarios were. So if we go back to the de-serializer factory, intentionally described the exception that we were throwing so that when the person goes, the other developer or we go to implement it, we throw the correct exception when we expect to. And then we have handling built in for that. And like I showed, I think extensively, it's really easy to test changes. Just make your change, build, run your tests. They're really fast. We're running in under seconds here. You can't find a faster way to do tests at the moment. Because you're running tests, you should be running tests all the time because they're so fast. You get higher product quality out of it. Because you get higher product quality, you effectively get increased development time in the future because you're spending less time fixing bugs in the future after you've already forgotten, how did I implement this? Why is this so weird? What is the customer trying to say about the product? How did they get into this scenario? You get to help out QA because you've already sort of pre-tested the build. You know what you're looking at as far as quality before QA ever gets to it. So you can be reasonably confident that what you've provided is a good build. It should pass all the QA tests, or at least pass most of them. You're severely reducing the risk of QA ever getting a bad build where nothing works or stuff is just generally broken. And they're really easy to do. The unit tests are really easy to do. The hardest part about even the demos, putting the demos together, was not actually writing the tests. It was doing the implementations for everything, for the deserializers, for refactoring repository. The tests themselves were actually the easiest piece of it. And this is coming from someone who has a civil engineering degree and not a software degree from college. And if I can do it, I firmly believe that you guys can do it. And if you don't want to do it, you can send the junior engineer to go do it. And if the junior engineer doesn't want to do it, you can send an intern to do it. It's that easy. And if you guys run into problems while you're writing your tests, contact support. They'll get bug reports set, or they'll make bug reports for you. We'll see what we can we will do what we can to fix the bugs for you. If you have ideas, if you have feature suggestions, let us know on ideas. That's probably the best place for them. And we'll see what we can do about getting those new features in. And I'm just really interested in seeing what you guys come up with as far as weird and wacky ways to test your code.
Awesome. Thanks so much, Nick. So I am going to go ahead and give everyone the ability to unmute themselves, see if we have any questions from the general audience. Nothing in the question panel at the moment.
Explained everything just so crisp and clean, and there's no confusion. Everyone's really excited to go write their tests.
Well, hey, Nick, it's Jacqueline out in the audience, and I just wanted to say thank you so much. This was a wonderful presentation. I was able to follow along also as a person not with a software-related or computer science-related degree. So thanks.
Hey, Nick, it's Marty. I'm a panelist on this presentation, but what can you do anything else with the Test Explorer? Like, is it good for navigating or grouping? Like, what can you do with it?
Yeah, so let me go back to our other project here, because there's more tests to work with and organize by. All right, so if we go back to how I did have these organized, right, we're looking at project, namespace, class, test method. And if we double click on this test, we should be going to the right item, but we aren't. So I think we have another bug in our tests here, Marty.
Oh, no.
No data. No data should have brought us here. So I think we are seeing an issue here. But we'll notice that I have JSON de-serializer as a test category on this. I have XML de-serializer on the XML de-serializer tests, and de-serializer factory on the de-serializer factory tests. If we come over to this group by button, you can see all the different ways you can organize your tests. So right now I have project namespace class. If we just uncheck some of these, class actually becomes the last thing, because you need to organize them by something. I'm assuming that it doesn't make sense to just throw all the tests at one level in the Test Explorer. That's really not great to organize them. But if we go to our traits, right? We see our de-serializer factory tests based on de-serializer tests. We see our subroutine because it has no traits on it. XML de-serializer. And because we have test file attributes on these, and they all have different values, or some of them have different values, we see those all appear here as well. So there is some duplication in here, but that's what you get when you have multiple traits on your test methods. But you can organize them however you want out of here. If they've passed or not, you can organize them by passing. And if I had any failing tests, you would see failing tests. Any other wants and asks about organization?
Nothing in the question panel yet.
Can you explain the difference between dark green icons and light green icons?
So the difference is the test that was run. So if I just run a single test here, right, this was the test that was run. It gives us our dark icon. Any of the tests that were run previously will have their same icon, just in a lighter version. So
Okay.
if we had,
so that means
icons,
it passed last time it ran.
Yeah. If we had failing tests, but didn't run the failing tests, we would see a light red icon if they didn't fail in the last test run.
Perfect. Thank you.
The last test run that we had executed, not their last test run.
Well, I don't see any hands up at the moment, and I still don't have any questions yet. So I'm going to tentatively start wrapping up the webinar. Thank you for joining us today. Again, keep an eye out for the recording of this presentation on YouTube. And in the meantime, you'll see a survey as you exit the webinar. Please consider offering your feedback. We would really appreciate it. And thanks again. We look forward to seeing you in a future webinar.